And that's why we're not recording.
All right. Cross off the chapter 7. We are only in chapter 6. This is our the wind and water problems. Okay. The setup for these are the same for the wind and water. We're going to make the same chart. We make a chart for these 4 problems. Okay. Say again.
Brennan's being
What's your
silly.
name? All right, quit wasting time. We got a lot to do. All right. Has anybody ever, or probably a lot of you guys, how many of you flown to the West Coast and back, California, or like back? Flown there, and then spent some time whatever flown back. Do you remember? You might not. It's really probably not important to you. Does it take longer to get there, or does it take longer to get back, or is it the same?
It takes longer to get back.
It depends.
It is the same. Great point.
It's
It is the same
but
distance.
the wind
Because the wind turns
depends.
Hold on, let me explain. It is the same distance from here. Let's say pretend you're going to San Francisco or LA. Okay, the distance from here to San Francisco is the same as it is from San Francisco to here. Think about that. Okay, but here's some of you guys should think about it. When you longer, but a significant amount longer, the pilots love flying back there in the air.
Jet stream.
The jet streams from the west towards us, from California towards us. Okay? And believe it or not, guys, you wouldn't think it would help that much. But wind way up there, you know, when you're 30,000 feet in the air, the wind really up there, guys, is on an average day, might be going 80 or 100 miles an hour. So when that plane's cruising, when it's going from San Francisco to here, those pilots use that jet, they try to get in the jet stream, and it saves them time, and it saves them jet fuel. Okay? Now, when they drive from here to there, when they fly from here to there, it takes longer. Maybe even 45 minutes or an hour longer. Because they have to fight that 100-mile-an-hour wind the whole way there. Okay? Now, have you guys ever been canoeing with your family?
Yes.
Okay? Do you ever canoe upstream?
No. Yeah, it's really hard.
It's not easy. You can do it, okay? But when you go on a canoe trip, you know, you got a guide or whatever, and you go to don't they always start you upstream and then you canoe down somewhere else to another place? You go downstream, and the current, you don't even have to canoe for a while. You just kind of sit there and your canoe goes. Does everybody agree with that? Ever done it? You guys, they would never take you downstream and say you got to get back upstream. Yeah, it would be tough. Okay? So, guys, these are wind and water problems. Here's my question now. And believe it or not, this is true. You're leaving San Francisco on a plane. You're coming back here. If your plane is going 400 miles an hour, the planes go that fast, 400 miles an hour, and the wind is going 100 miles an hour, guess how fast you're going?
500 miles an hour.
You're going 500 miles an hour. Okay? The wind will push you that much. But now, yeah, if you're going 400 miles an hour, you get the plane on the speedometer. I don't know if that plane has a odometer or speedometer. Do you think a plane has a speedometer?
No.
It's like an arrow.
No, I don't think it does. Probably some very technical instruments. Anyways, if your plane's says it's going 400 miles an hour, but that you're fighting that 100-mile-an-hour wind going to San Francisco, you're only going 300 miles an hour. Okay? So, this is what we're going to do today. Okay? Watch this. We're going to define 2 variables. Okay? And write a system of equations. We're going to use x and y again. If you want to use other variables, that's fine. But we're going to go back to x and y. X is going to stand for speed of either the plane or the boat or the canoe, whatever vehicle you're in. X is going to be the speed of that vehicle. Okay. Would somebody like to take a wild guess as far as what y is going to stand for?
The wind/water current.
Yeah, the speed of the wind or the current. Yes, you can. The speed of the wind or the current. Whatever's helping you when it's going with you, or you're fighting when you're going against it. You're going to get how to set these things up. All right, now, these are also basically considered distance problems. Hold on, Blake. These are considered distance problems. we need to write down the distance formula. Do you guys know the distance formula off the top of your head? I know we've gone over it at least a couple times. Guys, distance equals rate times time. And totally shorten that up by going D equals RT. That's one you're going to use a lot, especially with motion problems. We're going to use it twice in every problem. Okay, and that should make sense. Distance equals rate times time. How fast do your parents drive on the highway when you guys are going on vacation?
700.
You're not driving 100 miles an hour, Gardner.
75. 75.
Yeah.
90.
Well, what's the speed limit then? Let's go there.
Like 70.
We'll say it's 70. I don't know if it's 70 here. In Indiana, I know it's 70. So let's say you're driving 70 miles per hour. Can everybody picture driving 70 miles per hour?
Yeah.
Hey, going pretty fast. The lines are going quick. You're bored. You're looking at them. Okay. What if you drive 70 miles per hour for 4 hours? Okay.
You're gonna end up.
There's the rate. There's the time. That will equal your distance. Okay? Who can do that in their head? 280 what?
Miles.
Well, hey, is it miles per hour or just miles?
Miles.
It's miles. Guys, that's the distance formula. If you drive 70 miles per hour for 4 hours, multiply together, you've gone 280 miles. That's it. That's the distance formula. Put that in long-term memory now. You're going to use it a lot. All right, now let's try doing some of these. Okay. With the wind, an airplane travels 1,120 miles in 7 hours. Against the wind, it takes 8 hours. Okay? And then we're assuming it's going the same distance. Find the rate of the plane in still air. So that means what's the rate of the plane if there was no wind? And then find the rate or speed of the wind. Rate, do you guys know it means the same thing as speed? Okay, maybe I should have defined it as rate up there as well. All right, let's do this. X equals rate of plane, speed of plane. You want to write that down? That's fine. And Y is the rate of the wind. Okay? What's nice, and I don't know if that's nice, but here's about these problems, there's no other stuff to define. You don't have to write a bunch of other things down like the last two types we did. Question, Blake, go ahead.
Instead of plane, do we have to write plane or boat or whatever for the situation or wind or current for the situation? Can't we just like do speed of vehicle,
Sure.
speed of amplifier?
Sure, you can do that if you want to.
Okay.
I would write rate of plane and rate of wind, but you can do what you want. All right, now we're going to make a table. We're going to make a nice little table. Okay? Let me do it for you guys. Watch me do it, and then you guys do it. The table's going to have two kind of long rows. And then always to the left, I always put, it sticks out there at the end.
Oh.
Okay? And then it's going to have one. It's going to have 3 columns there in the middle. Anybody want to guess what the 3 columns are labeled?
With the
Rate.
Rate,
Time.
time, distance. And I always do it that way. I know I wrote a distance equals rate times time. I always go R times T equals D. Right above your table, it's always going to be the setup. Okay? And now, we got 2 things going on here. With the wind, that was what was mentioned first. So I'm going to say with. And if you write with wind as your first row, that's fine. And then I always write against as your second one. Okay? Looking at the variables that we set up, what's the speed of the plane with the wind included? Don't blurt it out if you know it. What's the rate or speed of the plane with the wind? Don't say it out loud! Michael! It's easy, believe it or not, people.
Yeah, John, you do it.
Okay, Paige.
160 miles per hour times 7 hours equals 1120. 1,020.
Okay, we're not going to. What she did is I think she divided 1120 by 7. Okay, but we can actually use our variables as a, and that's what we're going to use. Guess what the speed of the plane is using our
160 miles per
variables?
hour. XY.
Close, Gardner.
YX.
X plus
X minus Y.
Say it again, Murph.
X plus one.
Guys, your speed, we already mentioned this. The speed of your plane plus the wind pushing you is your rate, which, Paige, believe it or not, x plus y equals that number you gave us. But we don't know what x and y are. What was the time with the wind it took us to travel? 7 hours. Fill in your table with the correct numbers. The time is 7 hours. What was the distance that plane traveled?
1,120 miles.
Yeah, it's right here, 1,120 miles. Okay? Now, don't blurt it out if you know it. I want everybody to think about this one. What's your rate against the wind? Using x and y. Bulls.
X minus one.
X minus y. The speed of the plane fighting the wind.
And it's 8 hours.
Okay? Is 8 hours. Takes longer. And it's the same distance. So I'm going to put the same number in the distance. Okay?
Well, that's my
This
address.
setup, guys, is going to be real similar in all these problems. The rate with the wind or with the current is going to be x plus y. Against it, it's going to be x minus y. They usually tell us some time. They tell us some distance. Now, we're going to set up some equations, and I'm going to show you guys this little trick Ms. Perillo. 7, just because that's the number, times x plus y, okay, rate times time, but I just put the time first, equals 1,120. And 8 times x minus y equals 1,120. I just wrote a system of equations because rate times time equals distance. All right, distribute these things. I'm going to write it right here. Very easy. 7x plus 7y equals 1,120. And 8x minus 8y equals 1,120 as well. Okay, here's the trick Ms. Perillo told us because I started doing it a weird way. And not a weird way, just a long way. And this is why you need your calculator. What's the least amount of x's we can make?
56.
What about y's?
56.
Okay. So basically, does everybody agree we're going to multiply by 8 and 7?
Yeah.
You guys want to multiply those numbers by 8 and 7?
Yeah.
You can. Miss Perillo's like, I always show the kids you can actually divide by a certain number throughout everything and make it a lot smaller.
Divide everything by 7.
Yeah. So what I'm going to do is I'm going to divide, but this only works when these numbers are divisible by the two numbers you want to divide by. So somebody check to see if 1120 is divisible by 7.
It is 160.
Check to see if 1120 is divisible by 8.
It is 140.
Sweet. So we're going to, instead of multiplying, guys, and some kids have tried, I think Brandon was trying to do that a week or two ago. You can divide. Hey, you can divide by something to make your equation smaller. That's okay. So anyways, the first equation will be x plus y equals, what was that, 1120 divided by 7?
140. No, 160. 160.
I think it was
160.
I don't think it was 160.
It was.
Oh, it was 160? All right, thank you. And then x minus y
140.
equals 140. And
2x.
the equations are way smaller this way. If you multiply by 7 and 8, it's going to work out. You're just going to have big numbers to deal with. And if you have your calculator, so be it. All right, here we go. The y's eliminate because you got plus y minus y. Elimination works. We have 2x equals 300.
Yeah.
Divide by 2. X equals 150
Y equals 10.
miles per hour.
Oh yeah, I remember you saying these are gonna take up like a full page.
Yeah, they take a lot of space. 150 miles per hour. Now,
So we have to plug it in.
I would use one of the two equations from when we made them smaller. So I'm going to use this first equation. 150 plus y equals 160. Clearly y is 10 miles per hour. So this plane's going $150, and the wind's at 10 miles per hour. Okay? This must be some kind of like small airplane that's like flying out of a small airport. It's not like going out over here because 150 miles per hour is not very fast.
That's like private school.
Okay?
Well, it's barely just.
No. for the fourth time.
Listening.
For the fourth time today.
Sugar Ablar.
Holes, I worry about you. All right, so, you know, we try to make them work out evenly. If they don't, guys, just use your decimal, or, you know, you're going to need your calculator to do this stuff. So, page, back at the beginning, what was that number you told us?
160.
160. Guys, what's 150 plus 10?
160.
160.
Divide it.
What, Val?
Can't we just divide it to be easier?
But we didn't know the speed of each. We knew it was 160 together, but we didn't know it was broken up into 150 and 10. Okay? Yeah, all right, in a canoe race, a team paddles downstream 480 meters in 60 seconds. The same team makes the trip upstream in 80 seconds. It takes them longer to get upstream because you're fighting the current. Find the rate in still water and the rate of the current. Set up your variables. X equals rate of canoe, okay, in still water. That means if there was no current, X is how fast that thing's going. And Y is the rate or speed of the current. Okay? The current pushes them when they're going downstream, and it makes it difficult. It pushes them in the front when they're coming up upstream. Okay, do you guys know the difference between downstream and upstream?
Yeah.
Okay.
Down.
All right, make your table.
Well, if there's a hill, it would do.
Make that rate times time equals distance. Guys, you will get fast at making these tables. Okay? Since it talked about downstream first, I put that one first. Sometimes they'll tell you the upstream information first. I would put that upstream then first. But all right, downstream. Raise your hand if you know the rate. Val, what do you think? X plus Y. The rate of your canoe plus the current helps you. The time is 60 seconds. We're going to do this in seconds. And it's 480 meters. Okay, coming upstream, it's the same thing. The time is a little bit different. It takes a little bit longer. What's the rate you can travel coming upstream? X minus Y. Because you're going to fight the current. So, how many people see that the setup is basically the same in all these?
Gonna be like that though?
For the most part. They might throw you,
Like if you want.
they might say that the rate of, they might do something goofy like the rate of the wind is twice as strong on your return trip. So you would do 2Y. So those are the curveballs they could throw you. Paige.
Do we always have to draw the table?
Yes. You've got to set up a table. And you know, you can make it, yes, you do have to set up a table. You don't have to put all those lines in here. You know, if you want to make a table that, like that, makes it easier, that's fine, whatever. But yes, you have to do. All right, write your two equations. Oh, here's the next thing. You guys are all smart enough to distribute in your head. You don't have to write out these. No, these two. You can go right to these equations because I think you guys are all smart enough to distribute in your head. So you're going to go 60x plus 60y equals 480, and 80x minus 80y equals 480. I think you guys can all distribute in your first step. You don't have to write out 60 times the quantity and stuff like, you know, that. So just distribute. Are those numbers divisible by 60 and 80?
Yes.
Nice. Let's make those equations easier to deal with by dividing by 60 and dividing the second one by 80. When you do that, guys, usually your y's will eliminate.
So are we always gonna have it?
No, it's 7.
Are these numbers always going to be divisible by the two coefficients?
Probably not. So what do you do?
The next one it's not, but I'll show you what to do then. It's easy. You just use multiply.
Okay.
You know how to do it. X plus y equals, what's 480 divided by 60?
8.
8. Thank you. X minus y What's 48 divided by 80?
6.
6.
Y equals 1.
Those equations are so much easier to deal with. Go ahead, Blake.
Is that supposed to be 80x, or did you forget to write over 8x minus 1?
80x, thank you. Not 8x. All right, eliminate your y's. 2x equals 14. X equals 7. Okay? The canoe's only going 7 miles per hour.
7 meters per second.
Ah, meters per second, thank you, not miles per hour. Because the units, guys, were doing meters per second. What would you add to 7 to make 8? 1. Y equals 1 meter per second. So it's not that strong of a current. Make sure you do both of them. Is it possible, kids always ask this question, is it possible for the current or the wind to be bigger than the speed of the plane or the boat?
Yeah, because
You
the
should be
plane
going
is
like
speeding
that.
backwards.
Right, yeah, you'd be going, so is it possible for one of these problems?
No.
Oh no.
Y will never be bigger than X. It's impossible. You would never make the return trip. Okay?
Unless you went all the way back around, which is not.
Okay. So, talking about jet stream and wind and water problems. Okay. What if they give you the time in hour and minutes? This one always throws kids for a loop.
You make the
Okay.
hour into 60.
Or I think an easier way is make it all hours.
90 minutes.
I like 90.
Oh, okay, yeah, you could do that. You could either do 90 minutes. I would not do it that way. Or change it all into hours. What's 1 hour and 30 minutes in hours?
1.5.
Yeah, 1.5 hours. Those are the same thing. Because
That's pretty spicy.
there's 60. There's always the one kid that goes 1.3 hours. Do not do that.
I can see what's happening.
So you guys see where they do it?
Yeah.
How many? Hey, how many minutes would be in an hour if this was right?
100.
100. How many minutes are in an hour?
60.
60. So 30's half. Because yeah, some kids really do this, guys. They put 1 hour and 30 minutes is 1.3, or they do 1.30 hours.
Yeah, that's what I was asking.
Yeah, do not do that. So if you do it in minutes, your answer is going to be in kilometers per minute. If you do it in hours, it's going to be kilometers per hour. I'm going to use the 1.5 hours. That's the way I did it. Okay, both answers would be correct. They're not going to be exactly the same numbers, but they're both correct. Blake.
How many times when you're like, I always get this kid who does this, have you actually had the kid that does that?
I have no idea. Several.
Am I typically that kid?
I don't know. All right. It takes an airplane an hour and a half, or an hour and 30 minutes to fly 600 kilometers against the wind, and then the return trip with the wind takes only 1 hour. Find the speed of the plane in still air, and find the speed of the wind. Okay. So X and Y. Speed of the plane in still air. That means if there was no wind. Where Y is the speed of the wind. Okay, set those variables up. Make your table. Against the wind is listed first, so I'm going to do against first. If you want to do it below, that's fine. You just got to put the right numbers in the right spot.
I feel like negative wind, like going with you.
That'd be with the wind. Rate times time equals distance. Put that above your table, please. Okay, against the wind, our rate's actually going to be x minus y. So the x minus y goes first.
Oh, I flipped it.
Right, you gotta be careful and think about that.
Hey, what did you put with first?
Then that would be x plus y. And you're going to get the right answer. That's totally fine. So just your rows are going to be flip-flopped compared to what I have. The time, I'm going to use 1.5. If you use 90, you'll be fine. And the distance is 600. Coming back, or excuse me, with the wind, it's still 600. It's only an hour, and it's x plus y. Okay? 1.5x minus 1.5y equals 600, and x plus y equals 600.
I like this one.
Okay. So I think what we could do, since we've been doing that dividing thing, is we can divide the top equation by what number? 1.5. You got your calculators, do that. Divide 1.5, everything. These will just become x minus y. X minus y equals, what's 600 divided by 1.5? 400? And then x plus y, this one's not going to change, equals 600. That's that equation. Okay. 2x equals 1,000. How convenient. The plane is flying at 500 miles an hour.
No kilometers.
Right?
Y equals 100.
Did I do it right?
Oh, it's
Kilometers
2 hours.
2x. X plus x is 2x.
Kilometers.
Thank you. Now, did anybody use the 90?
I did.
What'd
I
you
did,
get?
But you
That's
couldn't.
not-
Say again?
You couldn't do.
Turn into a decimal.
Yeah, because you can't divide 600 by 90.
Ah, you might have to go with the 90. And then what'd you use for this one?
60.
You're smart, guys. If you use 90 for the 1 point for the time, you got to use the same kind of unit. So you got to change that. So 90 and 60, you got to probably change them to be 180s, or deal with that decimal when you divide. Either way, you'll get the right answer. What would you add to 500, guys, to make 600? 100. So the speed of the plane is 500 kilometers per hour, and the wind is 100 kilometers per hour. You got to get both of them. Please label things. Okay. Kilometers per second will probably be a smaller number. You know, if you're going 500 kilometers per hour. Actually, somebody divide 500 by 60. Somebody divide 500 by 60.
500.
What is it?
8.3.
8.3 repeating? So,
8.3.
the answer, if you do it in seconds instead of hours, you should get 8.3 kilometers per second. And then, what's 100 divided by 60?
8.3.
No.
No.
1 point something.
1.66.
1.6 kilometers per second. Or 2/3, yeah. So, if you did it in, I would accept both answers on a quiz. And just look at your work. If you did it in seconds, you're going to get the green. If you did it in hours, you're going to get the red. Paige.
Would it be kilometers per minute?
What's that?
Kilometers per minute.
Per minute. Thank you. Not seconds. If you were going 8.3 kilometers per second, I think you're going about the speed of light.
Yeah.
Or not the speed of light, the speed of sound, maybe. All right, last problem. You guys are doing great. A 4,200 kilometer trip from San Fran to New York takes 6 hours flying with the wind. Against the wind, the same plane can only travel 3,300 miles in the same time. Fine. So the distances are different. So the distances are different here.
But the time's the same.
But the time's the same. So, see if you can set up your variables, set up your table. Okay, we're flying with the wind first.
Do you have to do that on top?
No, you don't have to do that.
Just writing in still air, then that's necessary.
I would not count off if you didn't put in still air. Just make sure you know, because some people think the speed of the plane is x. Is that with the wind, against the wind? That's in still air.
Would they ever give you a problem where you don't find in still wind, find
No. The x and y will always be the speed of the plane in still air and the speed of the wind. Okay. So with the wind, it's x plus y. Against the wind, it's x minus y. The times are the same, 6 and 6. But the distances here are different, people. The first distance with the wind is 42 hundo. The second one is 3,300.
Wait, they're in
12x
different
equals
units.
3,500.
What do you mean they're different units?
One of them's kilometers, one of them's miles.
Typo.
I don't-
Change the miles. What do you want to go miles or kilometers?
Miles.
I like miles better too.
Yeah.
You're right. You cannot do it, guys. That's a typo.
We ever have a problem where like the wind changes halfway through the trip?
No, you gotta assume that the rate. What's that?
You gotta call Mrs. P and determine.
Oh, she'll catch on to it. All right, it's miles. Sorry about that, guys. Typo. All right, let's do this. Are 42 hundo and 3,300 divisible by 6?
Sure.
I sure hope so.
You can
6x?
do elimination.
What if you eliminate and then divide?
Yeah, wait, yeah, 12x equals
Because it's
7,500.
Wait. Why are you making 12 of them, Bob?
They're divisible.
Because you're adding it. If you
Oh,
lose-
oh.
yeah.
Can you do
Ah, you don't have to divide them. You guys are so smart. Much smarter than I am.
Yeah.
There's always one kid that divides everything by 6 to make them smaller. Or one teacher that does that.
I was thinking that. 625.
You don't, guys, you got this opposite amount of y's. You should go good to go here. 12x equals, the y's eliminate. 0, 0, 5, 7. Did I do that right? What's 7,500 divided by 12?
625.
How much?
625.
X equals 625. We change it to miles. Miles per hour. Okay? Now, this one we got to use our calculator to find y. We got to go 6 times 625 plus 6y equals, I'm going to do the 4,200 one. Really, I have to.
37. It's 350.
50 plus 6y equals 4,200. We got big numbers here.
Then you subtract 3,750 and you got 450 equals 6.
I don't think it's 450.
Yeah, it is.
Yeah,
It is.
Oh, it's 450?
Yeah.
Okay. Didn't seem like it was that number. Divide that by 6, JB.
75
75 what?
miles.
Okay. The wind is 75 miles per hour. The plane's going 625 miles per hour. Okay? So when you're going with the wind, you're actually going about 700 miles per hour. And when you're against the wind, you're actually going about 550 miles per hour. Because you would add them or subtract them depending on which one it is. All right. Guys, the setups are always the same. Make a table. X plus Y with the wind, with the current. X minus Y is against the current. Okay? Signing off, guys. Everybody say goodbye.
Bye. Have a nice day.
Keep